slow pace, but massive impacts? Not likely. Then, in 1980, came one of the most astonishing publications of my lifetime. A group of physicists and geologists in California announced evidence that the Earth had indeed been hit by a huge meteorite at around that time in the distant past, then dated to 65 million years ago, and that the consequences of this impact had wiped out much of life, including the dinosaurs. Their idea was met by instant ridicule and derision by most geologists and paleontologists, and yet it is broadly accepted now. This marks one of the biggest shifts in scientific opinion of recent decades. From being regarded as pariahs, the catastrophists, geologists who point to larger-than-normal crises in the geological past, have won the argument, in terms of extinctions of life in the past at least. In retrospect now, it is extraordinary to see how mainstream geologists denied the reality of catastrophes for so long. Their stance dates back to the 1830s and early debates in geology which were won by the uniformitarians, scientists who argued that everything in the past could be explained by reference to modern, slow-moving processes. As a result, it became pretty well impossible to discuss mass extinctions as we now understand them without being branded a madman. Now that it is considered acceptable to talk about sudden extinction events in the past, the end Cretaceous mass extinction has been more closely studied than any other. Dozens of scientific publications on the subject appear each year, and these are accompanied by hundreds of treatments in children's books, news items, and websites. This is partly because of the appeal of the dinosaurs. Everyone wants to know why they died out. But also, the end Cretaceous event was the last of several mass extinctions, and so it is easier to study. It's a general principle of geology and paleontology that the quality of information declines the further back in time one goes. An event that happened 66 million years ago is easier to date accurately, and associated fossils are more abundant, than an event that happened 252 million years ago. Near annihilation. The end-Permian mass extinction may be less well known than the end Cretaceous, but it was by far the biggest mass extinction of all time. Perhaps as few as 10% of species survived the end of the Permian, whereas 50% survived the end of the Cretaceous. 50% extinction was clearly significant enough, and it was associated with devastating environmental upheaval. The catalogue of crises 66 million years ago makes terrifying reading. The impact of a vast meteorite in the Caribbean, volcanism in India, major environmental deterioration, dust clouds, blacking out of the sun, freezing cold, acid rain, and dinosaurs going extinct on all sides. But there is an enormous difference between 50% survival through the end Cretaceous crisis and only 10% survival through the end Permian. The key difference between 50% survival and 10% survival is the diversity of founders available for the reflowering of life after the catastrophe. 50% of species should offer a reasonable cross-section of the range of organisms that existed before the event and the chance that the ecology of habitats on land and in the sea could eventually recover to something like a balanced system. But survival of only 10% of species means that many major groups of plants, animals, and microbes have probably gone forever. Life can be thought of best as a great tree, originating with a single founding species many billions of years ago, and continually branching and expanding upwards through time as new species arise. Here and there, twigs of the tree die off as species become extinct, but the overall shape of the tree expands ever upward. During a mass extinction, vast swaths of the tree are cut short as if attacked by crazed, axe-wielding madmen. Whole branches and twigs are brutally removed. The ragged remnants of the tree, though, will reshape themselves and grow back to full luxuriance. At the end of the Permian, however, the slashing of the tree of life was vicious and sustained. Entire regions of its diverse branches were cut and hacked off. After the crisis, only 10 in 100 of the branches remained, a pathetic remnant. There was certainly no guarantee that these would be sufficient to survive in the long term. After such a severe attack, the great tree of life, with over 3,000 million years of history behind it at the time, might have withered away and died completely. The fact that you are listening to this book is